Now, first of all, physical properties. Okay, so at the end of it, we want to use fingers and say, hey, this topic seems big. Is there really a lot of things? No. Later you see, by fingertips, there's only a few things. Okay, so let's take a look. First of all, atomic radii. Atomic radii, which is the radius itself. Now, I'll let you know first, in case you're not aware, B1, page 2, atomic radii, or is it page 3? Page 3. The atomic radii come out again. The word atomic radii is tested in many, many versions. Keyword versions. Different ways. Where is it? It come out here again, B7. Okay? So they are, why like that? Why split them out? Okay, let's take a look. Now, first of all, atomic radii, let's recap back, right? It's all about what? Atomic radii is all about the effective nuclear charge, right? All in all, hey, this one high or low? We need to talk about the nuclear charge. We need to talk about the shielding. Slow and steady, let me wake you up, okay? Ready? Here we go. Trend in atomic radii. Now, first of all, everyone highlight. This is, we are talking about the trend. Trend that is across the main group elements. Trend that is across the transition elements. So the question will specifically tell you the trend across main group, the trend across transition elements. It's not two elements. It's across a group of them. Okay, so all in all, what I'm going to show using the keywords, and you will be showing, all these are standard question, right? Is what? Is that it will decrease significantly. So when were we? Remember period 3? We learned period 3. We say, oh, they will decrease quite significantly. Correct? Remember period 3. What about transition metals? Ladies and gentlemen, transition metals, you are supposed to know, from one element to another element, they are quite similar. That is what they want to test you, especially MCQ. Please appreciate that. So for example, I'm talking about what? Anyone, right? Say sodium, magnesium, aluminum. Take our data booklet, take a look. Transition metal, including your scandium and zinc, I suppose. But never mind, let's play a bit safe. I'll say it's titanium. If drawing the circle in reminds you, please draw them in. Titanium, vanadium, chromium, blah, blah, blah. Left to right, how the size changes, the trend. So this can come in 3 ways in the question. First of all, it comes in first way, which is just asking you on main group elements. It could also come very simply on ask you how they change across transition element. And of course, they will then ask you to versus them. This is the baby. In period 3 come out, this is a lot of marks because you write a lot. So you cannot lose a single mark. This is at least 3 marks, confirmed, guaranteed per job. Can't be 2. Too much to write really. Right? So you want to swallow this now. Because this present come early. Agree, everyone? Done. So be very clear. Again, is among them. Left to right. Be careful. The trend from left to right side. So once again, let me just finish up, right? Left to right, what do you see? And the answer is there, okay? So here we go. For across the main group elements, the trend in the atomic radii is this. It will tend to decrease significantly, as you can see from my drawing. And these are all your babies. Orange color. The nuclear charge increases, obviously, 1 plus 1 proton. All right, as you left to right. And the electrons, if you look at it, are always added to the outermost or the valence shell. So you take magnesium, sodium, magnesium, aluminum, you know what's happening. Right out the EC, take a look. Which means the shielding effect remains relatively constant. Can I write out this word? Play more safe, relatively constant. They can't be constant. Okay, so if you look at my ENC formula, once again, I've introduced to you all. Right, this is about the same, but the nuclear charge increases. Obviously, the mathematical equation tell you effective nuclear charge increases very significantly. And from there, you should know what happened, the follow-up statement, right? So more attraction, stronger attraction of the valence shell to the positive nucleus, and therefore the size gets smaller and smaller and smaller, right? The decrease is quite significant. What about transition metal? Transition metal, the size, the trend, left to right, titanium to copper, let's say, it decreased very slightly. It remains relatively constant. Why I write all these words out? Because the MCQ, and also don't forget about paper 3, they will change the term accordingly. They all means the same. You probably see this word more often than not. Invariant. Please know this word invariant. Okay, so it means the same. So once again, what's the story? Go back to the ENC chart. All right, is whereby nuclear charge increases due to number of protons. Once again, +1, +1, +1 from element left to right. So this keep increasing. Then let's take a look at the electrons. The electrons are added to the inner 3D subshell. And therefore, the shielding as compared to the main group elements is a bit more. There is a difference between the red and the pink, and they expect you to acknowledge it. The shielding effect does increase a fair bit from one element to another. And therefore, you must agree with me that I am not too sure about the effective nuclear charge. It should be quite invariant, quite constant. Increase also won't increase too much. Therefore, we say the ENC only increases slightly. A small, tiny arrow if you want. And therefore, from left to right across the transition elements, you realize the size does decrease, but don't decrease too much. So as I mentioned, reading this is anywhere and everywhere. But are you very comfortable and confident about every sentence to a full stop? Or there are some sentences that you have a question mark in your head, but you're just too lazy to clarify on your own. That's the problem in transition metal. If not, the whole topic then easy. The difficult part is memorizing the colors. Ladies and gentlemen, is this one. Correct? Sounds okay, but are you sure? And that's the reason, ladies and gentlemen, why I wrote this out for your page 2. Because one look, I want you to be very comfortable in what you read in your school notes and my notes. Because these are standard questions. Take a look, ladies and gentlemen. Scandium, titanium, vanadium, chromium, manganese, let's say. All right. So every time you add an electron, or rather, take a look. It always go where? From here to here, right? So from D1 to D2 is always go into where? It's always go inside the inner D subshell. Everyone okay? Make sense? Yeah, lah, but in general, don't be ambitious. That is called general trend. Trend is always based on general trend. Take a look. That's why I want you to convince yourself. Then go back there again, you see? All right, take a look. Take a look. It always go inside there. Again, go back to manganese, right? So to iron, D6, D7, so on and so forth. Can you see not? They are subshell. Subshell shielding are not very strong. Everyone, are you with me? But there's still some shield. Agree with me? Make sense? So you go back to the ENC formula, it makes sense. And that's the reason why when there's increment, it won't increase too much. But yet there is increment. Are you with me? Make sense? So again, from here to here, inner subshell shielding are not very strong. But there's still some effect of shielding. So if I go back to the formula, if you take a look, I want 100% clarity here. Because transition metal is another topic. I would like to tell you, once you get it, you also don't have to come back on. The only time you come back here is look at the table, call what? Call the colors of ions. Because you got to memorize that, no choice. If not, it's all about clarity. Because everything can be chit-chat out. But you need to know your concept very well, right? Once again, if you look at it, So there are more and more electrons over there, right? That's why we also say what? The shielding can't be the same. There is some shielding, correct? I never say it's the same. Do you realize? There is a tiny arrow, some shielding. But this is a lot bigger. It keeps +1, right? Make sense? So you take long arrow minus short arrow. Hope you agree with me. There is also an arrow going up. The arrow won't be too big also, quite small. Make sense? Use length of arrow, consider that. So it increases, it decreases only slightly. But there is still a decrease. Can everyone? Because in school, I think a lot of schools, they use the word invariant because SEAB said they're going to test this word invariant. A lot of students, based on what I understand at the interview, they thought invariant equals to no change. They did change. They did increase slightly, or rather decrease slightly, sorry, in terms of the atomic radii, because the ENC does increase slightly. Can everyone? First one, all the best. Good luck to you. All right. So once again, done. So across the transition metal, across S block, and then compare them, S block versus transition metal. There is a trend, and everyone should be very clear. Ionic radii have always been like that. We talked about this before. The idea is the same, right? So it's just ion. If not, everything else is the same. As you can see, period 3 then decrease significantly. Transition invariant, all right? Reasons usually they say not required, but if not, the reason is similar to above, right? To the atomic radii. So again, think through it. Take 2 elements out and then discuss, all right? These are all your atomic structure as well as your periodicity, right? You've done this before. So go and take a look on your own.
If you would like to catch my latest videos, click on subscribe button right now. And click on the bell if you want to receive instant notifications once I've uploaded my latest video. If you would like to join my live chemistry classes and revision workshops, go on to winnerseducation.com and find out how you can score distinction for chemistry on a consistent basis, either in our center or online via Zoom. If you want to check out my online school, go on to passwithdistinction.teachable.com. You'll be able to learn chemistry concepts at your own pace and anywhere in the world, topic by topic. This is Sean Chua from Winners Education, to your distinction in chemistry.